SIW technology is becoming increasingly important for implementing circuits and antennas operating in the RF, microwave, and millimeter wave bands. This paradigm could lead to the integration of waveguide passive components, active devices, and radiating elements on the very same substrate, providing small size and low fabrication costs. Researchers from the Universitat Politécnica de Valencia have developed a frequency tunable microwave filter, as well as its design methodology, production, and packaging.
This patent consists on the development on reconfigurable filters based on a structure developed here at our research group called substrate integrated coaxial resonator. We have achieved to couple semiconductor varactors, ferroelectrics, and microelectromechanical systems to three-dimensional resonant structures, cavities, and we use these kind of components for the development of reconfigurable filters that can change frequency, bandwidth, or shape of response.
The technology is applicable to radio communications, satellites, radar, mobile communications, space and test equipment.
We know that future communication systems for both for many applications, military applications and also civil applications, for instance mobile communications systems or satellite applications, will need in the future of reconfigurable RF front ends. The need of reconfiguration is for providing services that can work at different frequencies, and at the same time it will be needed to provide different bandwidth capability in order to give support to many different applications on real time and covering different scenarios. So for the future development of RF front ends, all this reconfiguration capability will need of tunable and reconfigurable filters like the one we have just patented.
With the implemented filters, it is possible to have the electronic constant and/or discrete tuning for transmitters and recipients. It is therefore possible to reduce the number of necessary filters in the systems of communications, reducing the size and weight of the equipment.
The main advantages of this kind of component is the ability of change its behavior. So we can, for example, there are a lot of filters in every microwave, millimeter wave communication device. So with this kind of components, we can reduce the number of elements that we need, and also miniaturize the full system and introduce frequency adaptive capabilities to the environment or to the application that we cannot achieve with fixed components.
The manufacturing process is simple, low cost, and very well suited for mass production, which is of great interest for companies in the telecommunications market.
From this lab we have manufacturing capabilities with regard to the filter and to the tunable filters that we have shown you before. And the idea is also to make use of this manufacturing facility in order to produce a small series of products for future industrial customers that can ask us for these reconfigurable filters.
The Universitat Politécnica de Valencia offers the integration of this technology into customer applications with the required specifications.